Okay guys, so we're going to be looking at projects in general and power and the difference between some batteries and different types of motors. So we're going to look at the power needs of different components. Some are low power and others are high power consumers. We're going to look at the difference between voltage and amperage, batteries and their different sizes and capacities, and we'll compare that to buckets and spouts. We'll look at the different types of motors, the general different types of motors in Arduino projects, and the importance of torque. And we will also look at power adapters as a source of power for our projects. And then we will dive into a little bit of details of driving motors, considerations that need to be taken, and we will look at a project which is a camera slider. So let's go right into this and take a look at what we got for today. All right. Here, what we have is a rotating display. Okay, so this display has a servo motor down here, and we will look at a proper servo motor in a little while, and then we look more into details motors, but I just wanted to give you an example. So this is a simple servo that runs underneath, and we are going to power it. We've got a servo program loaded up in here, and we are going to power this with a 9-volt, and this is going to bring into focus the need to talk about power and motors together in a video. So I'm hooking up this 9-volt battery in here, and as you can see, that is a very slow spinning servo motor. That is not what is loaded onto the chip here, and that is not what a servo motor is capable of doing. Let me get this guy out of the way here, put this over here. I'm going to plug this USB into here. Okay, and I want you to keep an eye on this. When I power this up, there you go. Okay, so let's take a look at why this happened and how this relates to energy storage. So what we've got here is a 9-volt battery. However, 9-volt batteries do not have a lot of capacity in this little package. By comparison, this is a 3.7-volt battery, very similar to what you would find on a mobile device. And it is only 3.7 volts. Much the same as this is a 3.6 volt battery. And compare the size of this battery and this battery, and this is almost 3 times the voltage of this 3.6 volt battery. So what gives? The amount of energy stored in this battery is way bigger than the amount of energy stored in this battery, which means that at 3.7 volts, this battery package contains a lot more energy that it can deliver a lot faster when it is required through its cables. By contrast, this 9-volt battery is a very small package, and even though it can put out 9 volts, it holds way less energy than this battery. this is a homemade. Each one of these is 3.7 volts. So it's like one of these is 1, 2, 3. So this motor basically just runs back and forth, back and forth. You can either, depending on how you wire the power into this motor, you can make it spin in one direction or in the other direction. These motors are made more for speed, such as this car, and that's what would actually make this car work. So that's what this is. This stepper motor is a little bit more complicated, and this is it's got, as you can see, it's got 4 wires, so it's got 2 pairs of wires, and you've got yellow and red and green and gray in this case. And you saw how this worked in the ball screw, and you also will take a look at the video with the curtain. But basically this kind of motor is very good for a very fine control, because it will move step by step very, very precisely. And so there's a lot of these are used in industry, where you need a much finer grain control than you would normally need, as in the case of toys. And this here is the servo motor that we used in that rotating display. And basically servo motors work also by moving a certain number of degrees, or a certain number of well, those degrees can actually be controlled. You can tell it exactly how many degrees you want it to move, and it'll do so. And some of these are also, these are geared up on the inside. Okay, so what does gearing actually mean? Okay, so this is a non-geared DC motor, and basically any power that is produced by its spinning will be transferred out this shaft raw, as is, without any modification. These guys have gears inside, and or actually have gears that control this shaft. So whatever power gets produced in here, when powered in by those terminals, gets spat out the shaft, but it is controlled by these gears in here. And it's basically a trade-off between speed and torque. This has a very similar gearbox in here. Here's this exact same motor, but when it comes, before it comes out the shaft, it is converted into different torques, much in the same way that this guy is. And this guy has its gearbox in here. So this is the motor very similar to this motor, but this is the gearbox similar to this gearbox, similar to that gearbox, which can be used to convert speed into torque and vice versa, which is exactly the same concept as in the gearbox of a car. These, you'll see them, you have them everywhere, and basically whatever comes out of your mains is AC, but you want to take that AC, and most of our devices actually work on DC. So if you take a look over here, I don't think you can see it on the camera, but this usually has an input. In this case, it's 100 to 240 volts AC, and it has an output. And in this case, it's 5 volts, 1 amp. Okay, so this is powerful. This is 1 amp. This guy has an output of 5 volts and 1 amp, so this is very similar to that. Now this guy, which is one of those iPhone cubes, oh, you're definitely not going to see this, okay, but it has an amp reading on it. And some of these devices, they'll go 500 milliamps, 1 amp, 800 milliamps, and sometimes you'll run into some of them that put out 2 or 3 amps, which is quite rare, because 2 and 3 amps is not something that you want to get out of a consumer electronics device, you know, your typical mobile device or camera or whatever. It just won't need that much power. But when one of these batteries is just not enough, then you need to switch over to these guys. There are other sources of power that you can use for projects like this, such as the power bank that we saw earlier, but you can also just plug in USB cables into all of these, right? So they all use USB cables, and then you can plug that directly into the USB port of your board. Okay, so let's take a look at an example. In this case, okay, so this is an Arduino Mega, and this is a power source, and this is a stepper driver, which is what we use to connect to a stepper such as this one. And basically this stepper driver is able to get power from this 1, 2, 3, 4, 5, 6 times 1.5 is about 6, 7, 8, 9 volts. So this is a 9 volt, but compare the amount of power that you can store in this 9 volt with 6 of these. One of these is more than half one of these batteries. Okay, so if you have 6 of these, you're going to be able to get a lot more juice out of this guy, out of 6 of these guys, than you are going to get from these guys. So this is no good for a project like this. For that, you need 6 of those batteries, feed in power to your board, which feeds your motor, and feeds in power to your microcontroller, which in this case is an overkill because all I'm doing is running a stepper. I don't need an Arduino Mega, but it's just what I had available at the time, so that's what I'm working with here. Okay, so let's take a look at the code for the servo on the rotating display, and then we'll take a look at the code for the stepper motor that drives a camera slider. Okay, so here's the code for the servo motor. So we include a servo library, obviously, so we can have access to cool servo commands. And the first of which is to create a servo object. So every time that we create, or that we connect a real life object to the Arduino, we're basically going to have to create a virtual object that usually comes from a library so that we can communicate with the virtual object so that it can talk to the real life object. So here, servo is the object type and main servo is the name of our servo object. POS equal to 0 at the start, which is going to be the initial position. And then setup and loop as always. In setup, we initialize our serial monitor, and we also do the same thing for the main servo object, but it uses the main.attach, and it takes in the pin number that we are going to be connecting that object to. Now in the loop, we basically do a for block and 2 for blocks, one to go in one direction and the other one to go in the other direction. And a for is basically says this: for every time that the position is equal to 0, every time that the position is less than 180, add 1 to the position. So the position is 0, and because it is less than 180, it will add 1 to 0 until it reaches 180. And now we move over to the main servo.write. And what this does is it writes the value of POS to the main servo object, which is what actually makes the servo turn. Now we do the same thing, but in the opposite direction. So now that position is equal to 180, because we added 1 to 0 until we got to 180, every time that the position is greater than 0, which it is because it's greater than 180, because it is 180, then subtract 1 from that position equal to 180 until you get to 0. And then write that position value to the main servo. So this will make the servo go from 0 to 180, and then it'll make it go from 180 back down to 0, and then the loop will start again. Okay, so here's the camera slider example, and this is a stepper driving a ball screw. And this is a very typical project of camera filming projects. So you can use this to make more cinematic type videos than you would otherwise get from a standstill position. Okay, so for the stepper, once again, we include the stepper library. We define a few more variables in this case. One of them is steps per revolution, and we'll get into that in future videos. The other one is previous millis, and we will also get into that in future videos, as well as the interval one. But basically the previous millis and the interval variables are going to help us create a timer and keep track of time. Then, as expected, we create a stepper type object called myStepper, and we give it the steps per revolution we defined above, and the 4 pins because our stepper has 4 cables, so it needs to know what pins each cable will be connected to. Then we have the setup where we give some variables to the myStepper object, set speed to 70 for example, and then we initialize our serial monitor so that we can write to it for debugging purposes mostly. Okay, so let's move over to the loop, and here we do some neat stuff with this thing called millis. Millis is a function that returns the time that has elapsed ever since the program started running. So we store that into what's called current millis. And then we run another for loop. It says that for every time that I equals 0, if it is less than 10, add 1. We print the word negative, and we print the value of I to the serial monitor. We write that value to the stepper using myStepper.step. Then at the end of that for block, we delay for 2 seconds, and then we start the next for block. In the next one, we do the same thing. We're using A equal to 0, and we're adding 1 to it as long as A is less than 10. We write the positive symbols to the serial monitor and the value as well. And then we're actually going to write the steps per revolution to the step of the myStepper object. And then we're going to delay another 2 seconds and start the whole process over again. So again, this will make the stepper spin in one direction, then stop for 2 seconds, and then spin the stepper in the opposite direction. So it's a very nice pattern. Every object has a few variables or functions that you can use, and you basically just write to those. Okay, so I hope you enjoyed the video, and don't forget to like, share, and subscribe. See you in the next one.